Hello everyone, in this video we're going to look at optimizing attack. Our goal for this video is to reduce the amount of time between attacks, thereby increasing our attacks per second. All of the code in this video can be viewed on my GitHub. I will put a link in the description. The first thing I've done is to isolate the code not responsible for attacking into its own file. There's not much in here in terms of importance for the video, but it handles looting, moving, and regenerating HP and MP. Let's first take a look at some code to attack monsters that is equivalent to the starting code provided by the game. The code that I've highlighted tracks the amount of kills I get every 10 minutes and displays it on an overlay in the game, like so. I used this data to compare the different attacking scripts and compare their performance. As for the actual attacking logic, the highlighted code is functionally equivalent to the base code the game provides. So, how well does the base code perform? It's not terrible, but there's room for improvement. My character averaged 2,839 kills per hour. So, how can we improve this? Well, in our first attempt, we checked if we could attack every 250 milliseconds. What if we just checked if we could attack continuously, using a while loop? In computer science, this is called a busy loop. It's the programming equivalent of repeatedly asking your parents, "Are we there yet?" on a road trip. So, how well does this script perform? In short, it doesn't. Unfortunately, as soon as you start the code, the game stops responding. Let's return to our original code and just tweak it a bit. The biggest change we make here is looping every 10 milliseconds instead of every 250. However, changing only that would be a little dangerous. If we were on a server with a high ping, let's say 200 milliseconds, we could have a scenario where we spam 20 attacks and have the server disconnect our character for sending too many commands. We can fix this by first declaring our function async. By declaring our function async, we can take advantage of await. By adding await in front of our attack command, the code will wait for the attack command to resolve its promise. With these changes, we see an increase of 6% in our attacks per hour. Our next optimization is to change our loop so it doesn't have to loop every X milliseconds and check if our character is ready to attack. Instead, we will use data from the game that tells us when we can perform our next attack. If we were only able to attack once per second, this change could potentially save us 99 checks every second. Note that we're not using set interval anymore, we're just using a standard function. The try catch is also important. If we didn't have it, and our loop encountered an error, it would stop all future attacks. The most important change is here. We are now using set timeout. This line of code will call the function again recursively in however many milliseconds we tell it to. We set the timeout to the maximum of either 1 millisecond or the number of milliseconds until we can perform our next attack. The ms to next skill function is a function I made and is defined in base.js. It uses the data available from the game's parent.nextSkill variable. This variable is automatically updated by the game after every attack. Altogether, these changes only provided a 0.5% increase in our attacks per hour. However, the number of times we had to check if we could attack was reduced by 2 orders of magnitude. At this point, we have attacking logic that runs more efficiently and provides more attacks per hour than the base code provided by the game. But there's still at least one more easy improvement we can make. The next optimization we're going to make is to optimize for the ping between our client and the server. Maybe somewhat surprisingly, we only have to add one additional line of code to do this. Here, we use the game's built-in reduce cooldown function. This alters the previously mentioned parent.nextSkill variable and reduces the attack cooldown by however many milliseconds we want. I decided to conservatively reduce it by the fastest ping we have experienced between the client and the server. If we reduce it too much, we may end up sending an attack command too early and have to wait a ping cycle for the game to tell us we did so. This change provided my character a huge 12% increase in attacks per hour over our last script, or a 20% increase over the original base code. The last optimization I tried was to send multiple attack commands around the minimum ping, with the idea that it could compensate for small variations in ping. The logic in this script is quite a bit more complicated. Essentially, this script sends 9 attack commands, 1 every millisecond, around the minimum ping. You do have to be a little careful running this script, as it sends additional attack commands, which could make your bot disconnect if it does a lot in other parts of its code. I didn't see much benefit from trying this myself, but if your ping jitter is really high, it might be worth experimenting with it. Taking a look at the various methods, I strongly recommend the reduced cooldown approach with the minimum ping. It has worked very well for me, and I use this in my own code. The multiple attack strategy has too high of a code cost for me to be comfortable using it. Alright, that's it! I hope you use this knowledge to make your bots a little more efficient. If you have any additional ideas, questions, or anything you want to say, feel free to leave a comment or post on the Adventure.Land Discord. Thanks for watching.